Welcome back to Manish Kumar channel. So today we are going to discuss about the problems on continuity. So uh, first problem is show that function fc equal to c cube is continuous at z equal to c naught. Z naught is any arbitrary point in the complex plane, right? So to prove uh, fc equal to c cube is continuous at z naught, we need to show that limit z tends to z naught, fc equal to fc naught, right? Both should exist first and they all are equal. That is the three condition we have discussed in the previous video, right? And when you plug it, this is going to be equal. So this is the condition for continuity. Now we want to see the same problem using epsilon delta setup. So let epsilon greater than 0. We want to find delta greater than 0 such that whenever mod z minus z naught is less than delta, it does follow. You see fc minus fc naught is equal to z cube minus z naught cube, which is less than epsilon, right? So here for given epsilon or for all epsilon, we can say, right? And we have to find such a delta. So now the factor is the difference of cubes, right? So you know the formula. So using the formula we have written, and again we can also write this modulus because mod of ax, right, is equal to mod of a mod of x. In some way we are going to write, right? So here modulus wise we are going to write, okay? And then I want to estimate this factor. So assume that mod of z minus z naught is less than 1, right? Which will play a role of delta basically, right? This mod z minus z naught is less than delta, okay? So I can always write, you see, mod z can be written as mod z minus z naught and plus z naught, right? So here what had happened, I'm using the triangular inequality mod z minus z naught and which is less than or equal to plus mod z naught, right? And this guy is less than 1, right? Already given. So I can replace strictly less than mod of z naught plus 1, right? This is the value plus 1 strictly less than, and this is z naught. So I can find this mod of z is strictly less than or equal to is less than or equal to z naught plus 1, right? Then how am I going to find the estimate? You see here z square plus z naught plus z naught square, which is less than or equal to, you see here again triangular inequality mod c square plus mod c naught and plus mod c naught square, right? And then you see here what is the value of mod c. So I'm plugging it this value. So mod c square is nothing but this square, right? So we have replaced mod c square is by mod c plus 1 whole square. And already you see mod z, again mod z1 z naught plus 1, and again all of them are in mod z naught, right? So this term, if you see, this terms is a constant depending on your z naught, right? So we can set that constant as m, and then in that case what we can see, fc minus fc naught is less than or equal to z minus z naught into m, right? And which is less than epsilon, right? So in the very next line, what am I going to do is, since m is, always if you see whatever the z value is, z naught is going to be, this is going to be always a positive quantity, right? Right? You see here in this condition, all right? So you can always find such positive conditions, right? Mod C naught, mod whatever it is, modulus Z is going to be a positive quantity. This is also a positive quantity. This is also a positive quantity, and this is also a positive quantity, right? So your M is basically greater than zero, I can say, right? So now I can divide this M to this epsilon, right? And then we can find Z minus Z naught is less than delta condition whenever your Fz minus Fz naught is less than epsilon by M, right? So I found, you see, two conditions. One is mod Z minus Z naught, mod Z minus Z naught is less than 1, right? And another condition, we found that mod Z minus Z naught is less than epsilon by M, right? Epsilon by M. So this is a delta actually. So now delta is coming out to be 1 and epsilon by M. So we have to choose the minimum delta, right? Minimum corresponding to either this or this. So such a delta exists, right? It means that the given function is continuous. You see here, to make this less than epsilon, we choose delta is minimum of 1 and epsilon by M, right? Then for all z such that z minus z naught is less than delta, we have fz minus fz naught is less than epsilon, right? Therefore, you can say that your fc equal to z cube is continuous at z equal to z naught. So by both the definition, we have proved this. This is just like a polynomial function, right? So this is continuous. As you know already, the real polynomial and similar to the complex polynomial is also going to be continuous at z naught. Even this is differentiable as well, that you know already, right? So now you can generalize even this z equal to n also is going to be continuous, because here we have solved the problem n equal to, you know, 3. You got it? So let us see next problem. Show that fc equal to 2z square if z not equal to z naught, right? So where z naught is not equal to 0 is the discontinuous, right, at z equal to z naught. So now if you see this problem solution, so determine whether fc is discontinuous at z naught. We need to check this condition. And when you compute z not equal to z naught, you will find this, and when you plug z equal to z naught, you will get 2 z naught square, right? And in the second step, you will find the function value at z naught. What is the function value at z naught? 0. But limiting value is 2z naught square, right? So here these two limits are not equal. It means that function is discontinuous. And now you can make this function to be continuous while defining your function as to be, you can remove this 0 and you can define the function as 2z naught square, right? So that is possible. You can make this function to be continuous, because if you define if z not equal to z naught, 2z square, and if z equal to z naught, you can say that 2z naught square, then both values are going to be equal and then function becomes continuous. So such type of discontinuity is called removable discontinuity. You can remove that discontinuity while redefining your function, right? That is a very important point. Okay, so therefore this function is discontinuous at z equal to z naught. So we can see few more problems. So here we have to find z such that the following functions are continuous. What are the values of the z here? So if you see here, this is 2z upon z divided by z square plus 4, which can be further broken down into this way. And second part, 2 cosecant z. So let us see the solution. So you see, this function is a rational function, and rational functions are continuous whenever the denominator is non-zero. So set the denominator equal to 0 to get those points where function is not continuous, and then we will remove those points from the entire domain C, right? So after solving this, we got z equal to plus minus 2i. So this function is continuous on all z in C except these 2 points. So we have to remove it. Okay. Similarly, if you see, cosecant z can be written as 1 by sine z, and then sine z is undefined for every uh, you know multiple of pi. Okay. So now you see, we have to remove this points from complex plane. Okay. Discuss the continuity of the following complex valued function, right, at x comma y equal to 0, right? So z equal to 0, basically they want to say. So here you can think of like fc also you can write, or x comma y you can write. Okay. This can be written as, you can say, real z, right? This can be written as imaginary z, right? Which is going to be x into y. And this can be written as modulus of z, right? So in some way you can write into the complex way, but you can also find, you can write in this way as well, right? So if you see, how to define, so it's going to be this, right? So because mod c is square root of x square plus y square, so mod c square is going to be x square plus y square square root whole square, right? So you can write in the same way as well this function, and you can say that z not equal to 0, z equal to 0. So you can see, this function can be defined even in complex way. So there are several setup you can write the function, right? So these are the functions which we are going to define. Okay. So we will do one by one. Okay. So now if you write this function fc x comma y, x y divided by x square plus y square. So approach along different paths. So different path test will say whether function is continuous or not. So along y equal to x, you can replace xx, and then your function will give half value. And when you see along y equal to 0, then your function will give 0 value. So two different limit by two different paths. And now you take limit z tends to x tends to 0, and then you can figure it out. There is no x involved in the right hand side, so you will get always half limit, right? Similarly, y tends to 0, then you'll get 0 0. So function is not continuous at 0 0 because limit two different path test or fails, right? Similarly, you can do the second part using polar form, right? You can find it, and then you will find sine theta. So theta varies, and then values you are going to get changed. So limit depends on theta. So limit does not exist. So if limit does not exist, so function is not continuous at that point 0 0, right? Similarly, you can solve this function as well. So both numerator and denominator are continuous, and denominator is never 0 at the point 0 0, right? So in that case, f is continuous uh, everywhere, including even 0 0 also. So f is continuous at 0 0, right? Now if you see, the fx y is equal to x y modulus, so absolute value and then multiplications are continuous functions, right? Okay, so if you see here, therefore the composition modulus of x into y is also continuous everywhere. That we have already seen. F is continuous, G is continuous, right? Then, you see multiplications x comma y is continuous, absolute value is continuous. So this is just kind of your theorem result, which we have talked about in the theory. Composition function is also continuous. So using that, you can directly say, right? Similarly, you can see this problem, right? And then this is also continuous. Okay. So all of them are going to be continuous. Okay. So this is an exercise problem for you to solve, right? Check whether it is continuous or not. Thank you very much. Please like and subscribe this video.